I think we're ready to get started. Thank you everyone for coming. This is great attendance, welcome. All right, so we're here to build an application together. We're going to be building a summarizer for GitHub issues. We'll be looking at the Kubeflow platform. We'll build an application from end to end. So I'll start off with introductions. This is Amy Unruh. She's based in Seattle. My name is Michelle Casbon. I'm based in San Francisco. We're both engineers at Google involved in the Kubeflow project. And we have a couple of our colleagues with us today. We have Dan Sanchi, if you could raise your hand, and Steve Greenberg. They're both from Seattle. They're based here locally. We have Gonzalo Mesa from Sunnyvale, not far from me. And we have Sarah Maddox all the way from Sydney, Australia. Has anyone been to the Kubeflow website before, kubeflow.org? We have Sarah to thank for pretty much every word on that website. She's a very talented tech writer. So they're all here to help you. If you have questions, just raise your hand, and they'll help you resolve any sort of technical issues as you walk through things. And if you want us to explain some of the theoretical aspects, just raise your hand, and Amy and I can address that. All right, so we'll start off with what Kubeflow is. If you're not familiar with it, it's a framework for running machine learning frameworks on the Kubernetes framework. You get the idea. So if I could sum it up in just a few sentences, the Kubeflow platform is a curated set of compatible tools and artifacts that lays a foundation for running production machine learning apps. It enables consistency across deployments by providing Kubernetes object templates that bring together disparate components. But we'll generally be talking about three distinct layers. We have our application layer. That's the GitHub issue summarizer that we'll all be building. We have the platform layer, that's Kubeflow itself. And then we have our infrastructure layer. That's everything running on the Google Cloud platform. That's our compute instances, our GKE, our Kubernetes engine, Kubernetes cluster, our storage layer, and any services that we call at the GCP layer. So you can tell which layer we're talking about by looking at this little icon at the top corner. It'll be highlighted depending on the layer that we're talking about. So Kubeflow is exactly a year old. It was launched at KubeCon last year, last December. It's completely open source. You can find it on GitHub. It was launched by some Google engineers, but it's been really embraced by the community. This is a subset of companies that have contributed to the platform. It's not just open source, but we have an open community, open design, and we're open to ideas. So if you'd like to get involved, many different ways to do that. You can submit PRs or issues directly on GitHub. There's also a Slack team. You can follow us on Twitter, join a mailing list. We have a weekly call that alternates time zones because we're a worldwide distributed project. We have contributors from all over the world. So hopefully one of those times works for you. And we are just planning our second contributor summit. We had the first one back in September. It was the first time that we all met in the same room in person. Sarah was also there, all the way from Australia. We set up Hangouts so you can still be involved in both the presentations and the breakout sessions, even if you're joining remotely. Okay, so if you can go to this link in your browsers, this is all the documentation you'll need for your code lab. You don't need anything special. You'll be able to do everything within a browser. This is a special code lab that we built just for this event. It's brand new, so you get to test drive it for the first time. And what we'll run through today, we will set up our environment and then create a cluster from scratch. That'll include a default Kubeflow install with all the objects that you need, all the components. And from there, we'll move into the Kubeflow pipelines dashboard. We'll run a pipeline from scratch. We'll watch that, train a model, create a serving container, and then a UI that we can interact with. From there, we'll move into Jupyter Hub. We will create a pipeline from within a notebook. We'll use the pipelines SDK. It's in Python. And once we're done with that, we'll destroy our clusters and clean everything up. So we're going to shard our zones. So if you're on this side of the room, please use the west zone. That's US West 1B. And if you're on this side of the room, please use the US East 1C. We'll be setting some environment variables in the beginning. So please remember your zone. Write it down if you need to. We'll bring the slide up again later. But those zones are going to be pretty important. All right, do you want to get started?
Yes.
Set up the environment?
All right. So everyone should have, should see a little slip of paper at their desk that has a login and password. And raise your hand if you don't see one, or don't see one at an unoccupied seat near you, and the TAs can get you one. And just grab one from an empty seat if there's one nearby.
So you don't have to use your own login. You can go ahead and use these. We're footing the bill for it. You don't have to use your own resources. And everything, the environment should be set up with everything you need.
Okay. So does everyone have this CodeLab link? This is where you're going to live for the rest of the workshop. All right. Okay. So what we're going to do is work entirely. You're going to use that login and password to create a GCP, Google Cloud Platform account, temporary account. It's going to go away shortly at the end of the day, and you're going to be able to work entirely in the web browser and in the Cloud Shell, which I'll show you in a second. So you don't need to worry about having anything installed on your laptop. Okay. One other thing that you optionally need, so this CodeLab account gives you the criteria of an active GCP project. One other thing that you're going to need is a GitHub account. It's not absolutely crucial. If you're not on GitHub, there's just a step you can skip, and something won't work quite as well as it would otherwise. But it's not a deal breaker. But if you have a GitHub account, we're going to use it to create an API token shortly. Okay. So as you can probably tell, the way to navigate these CodeLabs is you can either click on the steps in the left-hand panel, or you can just click these left and right arrows. So everyone navigate to step 2, setting up the environment. Okay. So click on that, open the GCP console button. Oh, I recommend that you do this in an incognito browser window. So that way you won't have to worry about any other logins you have set up, even if it's like a Google Gmail login, fighting with your CodeLab login. So create an incognito window and browser window and work in it for the rest of the workshop. At least that's my recommendation. Once you've done that, log in, and once you're logged in, you'll reach a console panel that looks something like this. Let me make all of this just a little bigger. Minus the bottom panel. And navigate, if you need to, navigate to this home panel once you're logged in. And then click on this this button right here. It's in the little right-hand row of buttons. It's the first one in the list, and this is the Cloud Shell icon. So I already have a Cloud Shell running. That's this bottom panel right here, so I won't click it again. Click that to bring up a Cloud Shell. And the first time you do that, it can sometimes take just a little bit of time to provision. Okay, how is everyone going with that? And any unexpected questions? Okay. So if you have a question, just wave your hands, and one of the TAs will help catch you up. So activate the Cloud Shell. And while that's provisioning, create a GitHub API token if you don't already have one. So that's the step here. I'm not going to go through that because I've already created one, but click on this link right here. You need to be logged into GitHub, obviously. Create a new token. You don't need to give any scopes to it. And save it somewhere so that you can use it later.
And the reason we're using that is because we're calling the GitHub API, and with all of these people repeatedly calling it at the same time, anonymizing it from the same IP address will result in errors. So all you're doing is authenticating as a human rather than an anonymous user.
Yes. And once you've done that, and once your Cloud Shell is fired up, you can export it. So you'll have it in the Cloud Shell as an environment variable.
And just as a warning, if at any point your Cloud Shell times out, if you don't use it for a while, you'll lose those environment variables. So if you want to
Yeah.
sort of save those to a text file somewhere else and then copy them in.
Mm-hmm. Okay, so the next thing we're going to do is set a few more environment variables. And the first of them entails finding your project ID for this temporary CodeLab account. So go to the, if you're not already there, go to this home page or home panel in the Cloud Console and look for the project ID and copy that. So we're going to set it in the Cloud Shell as an environment variable. You're going to need to use this project ID a number of times during the workshop.
Can everyone see this? Is it large enough? Do we need to zoom in some? If you have trouble seeing it, just raise your hand and we can zoom in.
Yeah, just give me a heads up if anything's too small. Okay. All right, so let's set some variables. So you can just do the same as I'm doing. You can cut and paste from the CodeLab and edit appropriately in the Cloud Shell. So you're setting these in the Cloud Shell, not in your local terminal window.
Yeah, anytime we talk about using the terminal window, we're talking about the Cloud Shell.
Yeah, or the command line, yeah. I'm going to cheat a little bit with mine. Okay, so I'm going to, so when you set your zone, let me go back to this slide. This side of the room was west.
Like if you're
US
staring
West
at the
1B.
United States. West on this side, east on this side.
This side of the room is US East 1C. That's your zone. Okay.
Those letters are important because GPUs aren't supported in every region. So,
So we're picking these two so we ensure that we're using regions or zones that have GPUs. Okay, so I am going to use US West 1B myself. I'm setting that. Set your project ID to the project ID that you found in this home panel here. Okay. And you need to make sure that your Cloud Shell is set up to be configured to use your temporary CodeLab project. And you can do that by running this command here, once you've set your project ID. And then we're finally going to do one more thing, is we're going to, so G-Cloud, if you're not familiar, is the Google Cloud Platform SDK that lets you do a lot of useful stuff from the command line. We're going to, finally, we're going to set the zone that we're using to the zone that you were assigned, like that. Okay, I'm going to do one more visit of this slide so you can stare at the strings of the zones. Okay. All right. So the next thing we're going to do is create a Google Cloud Storage bucket. And the Kubeflow pipeline that we're going to run a little bit later in the workshop is going to use this Cloud Storage bucket as a workspace. So you can create it in two ways. You can do it from the command line, like this. You can give it any name you like, but it needs to actually be unique across all buckets. And so this is a good way to ensure that it is, including your project ID in the name of the bucket. Then you know it's unique. If you'd rather, you can create a bucket from the Cloud Console, and let me just show you what that looks like. Scroll down to Storage here. And you can actually, if you want to, you can pin these guys so you can reach them easier. So I've just pinned storage so it appears up at the top. And you can see I've already got a few buckets created. If I were going to create another one, I'd click Create Bucket and fill in the unique name. You can leave all the other defaults the same and hit Create. So you can create your bucket either from the command line or from the UI, the Cloud Console UI, and just make note of the name. So you'll need it later. Okay. Next, what we're going to do is install on the command line the Kubeflow, so this is the Cloud Shell command line, the Kubeflow Pipelines SDK. This requires Python 3, so we're using pip 3, and just cut and paste this command. And by the way, I believe if your Cloud Shell idles out, you'll need to reinstall it. Okay. How's everyone doing? Any big glitches? None. Great. Okay. All right. So the next thing we're going to do, now we've done some environment variable setup, is we're going to start the process of deploying the cluster. So what this is going to do, it's going to use Google Kubernetes engine, which we often call GKE, which is Google's managed Kubernetes. And we're going to install Kubeflow and Kubeflow pipelines on top of that. And we're also going to do some setup. We're going to be abbreviating this IAP, which stands for Google's Identity Aware Proxy, which sets up an authenticated endpoint. So just not anyone can get to your cluster. Okay. So click on this Open Kubeflow Click to Deploy button. Be sure you do this in the same browser window in which you've logged into your CodeLab account, because you're going to need to it's going to need to authenticate with that account. So if you're using an incognito window, for example, you probably want to do it in the same incognito window. I already got mine up. It should look like this. Okay. The zones, yes. All right. And in fact, you're going to need your assigned zone for this click to deploy launcher. So brand it on your memory. All right. Okay. So once you've done a little bit of setup, this is just like push button, create, and install of all this stuff. The setup, the first time, needs a little bit of attention. There are some steps that it's easy to get wrong. So if this is like the time to pay attention. If you were zoning out a little bit, pay attention now while we talk about this setup. Okay. So the first thing we need to do is enter our project ID. So again, that was, you can get that by going to the home panel and looking for a project ID here. That goes in the first field. For the deployment name, set it to be KubeCon, so not the default. Set it to be KubeCon. And this actually can be anything, but the code lab assumes that you're using KubeCon. So, so it's just simpler to do that so that there's one less variable to pay attention to. So project ID, deployment name is KubeCon. Okay, I'll come back to these two fields in a second. These are the fiddly ones. Select, for GKE zone, select the zone that you were told to use in the slide, which is either US West 1B or US East 1C. Those are your zone choices. Okay. All right, so here's the somewhat fiddly part. We need to set up some OAuth for the IAP setup, the Identity Aware Proxy setup. And there, if you go to the code lab, you'll see some instructions here about how to do that. Click on this button to bring up the tab with instructions. This just comes from the documentation. So when you click, you should get a tab like this. And we're going to need to fill out two screens. So the first one is the so-called consent screen. These are both under APIs and services, and then credentials. There's a link in the code lab that takes you to these, but APIs and services, credentials. Okay, we're going to do some setup here. First, click on OAuth consent screen. So keep the application type as public. Let me make this just a little bit bigger. Everyone see that okay? The name of the app can be anything, but just call it Kubeflow or something like that so that it's, you remember what it's for. The email, I think should be already filled in and should be the email associated with your CodeLab account. Okay. So here's fiddly part number one. You need to indicate the authorized domains. And that looks like this, where the first part is your project ID, .cloud.goog. That's the authorized domain. So you can see that's what I've entered here. This is the CodeLab account I'm working with, .cloud.goog. When you're done, okay, so this, everyone needs to listen to this. It's a UI glitch in my opinion, that makes this a little difficult. Once you're done entering this, click outside or hit enter or something to enter the information so that you get a field that looks like this, rather than an active field that you're typing into, if that makes sense. So make sure once you're done filling it in, click outside that field, like so that it looks like this. Okay, and then when you're done, click. You don't need to worry about the rest of these fields. When you're done, click save. Okay, so that's fiddly part number one. All right, fiddly part number two. So we finished setting up the consent screen. Now we need to create some credentials. So still in the credentials panel, we'll do create credentials and then click OAuth client ID. Okay, so credentials, create credentials,
You zoomed in too far.
yeah, and OAuth client ID. I actually have to reload.
Try just zooming out of it.
Oh.
Might be because there's no space.
Oh, yeah, maybe so. Click back. Yeah, okay. Create credentials, OAuth client ID. Application type is web application. Okay. You can give it whatever name you like. Again, you might want to make it something kind of intuitive, like that. Okay. Now, you're going to need to construct an authorized redirect URI. And it needs to have this structure of the highlighted bit I've got here on the top of the screen, where name is your deployment name. So if you followed instructions, that should be KubeCon. So this part is KubeCon. The project is your project ID string, okay? And so that's under authorized redirect URIs. So paste that in from the doc, and then edit these template bits to match your deployment name, which again should be KubeCon if you followed the instructions, and the project ID that you've got, like this. Okay. And then again, this is the crucial bit. Everyone pay attention. Once you're done, click outside the box. I know. And make sure you get something that looks like this before you click create. Okay. I've already done this once, so I'm actually going to cancel out of mine. You would click create. Okay. And then once you've done that, you'll be given once you've created it, you'll be given a client ID and a client secret. These are the values that need to go in that click to deploy web page. So client ID, let me make this a little bigger again. I'm okay to show you my secret because this project is going to be torn down shortly. Normally you wouldn't want to share that. Client ID and client secret. These go in the form fields here. Oh yeah, good to record the client secret on camera. No, I'm just kidding. We're gonna tear it down. No worries. All right. Okay. So you should have a screen that looks kind of like this now. And now we're going to click Create Deployment. And that'll take just a little while, so we'll go back to the slides for a bit while that's running. You should see a little... Well, this is a new error.
Do you have other clusters on that project?
I do, yeah. I actually have another backup cluster running, so I think I'll switch to that for the rest of the walkthroughs. I don't believe they should see this, should they?
Because you all should have quota. These are fresh accounts.
Yeah.
Who else is seeing a quota exceeded error?
Oh, really? With fresh accounts, that shouldn't be the case. Plus,
Default requests per minute per project. That's
yeah, per minute. Yeah, shouldn't be.
Maybe give it another 60
let's,
seconds.
All right, yeah.
I wonder if there's some IP throttling going
Yeah.
on.
I wonder if there's some kind of throttling as we all try to do this at once.
Is Richard here? Who's in the back?
Mm-hmm.
Okay. So give it another 60 seconds.
Mm-hmm.
And then try again.
Okay, actually, when I tried again, it went through. So I think it was just like everyone clicking that button all at once. Let's see if we space it out a little. It works a little bit better. All right. So that's going to take a little while to spin up, and so we'll go back to talking about Kubeflow for a little bit. If you got the same error, just give it a minute and try again, and I think it should work.
And what's happening here, if you want to watch your cluster spinning up, if you go into the GCP console into Kubernetes engine, you'll be able to see the cluster nodes spinning up. And as Kubeflow is installed on top of your cluster, you can see in the Workloads tab, you can see all the Kubeflow components.
Mm-hmm. Yeah, so that looks like this. Go down the left-hand panel till you find Kubernetes engine. You might want to pin it so you can get to it easily. So it pops up to the top. And you can see the cluster spinning up here. When it's done spinning up, it'll get a green check mark. Oh, the auth process? Yeah. So that was, just to follow the breadcrumb trail back, that was, so this is in the Code Lab page. This link takes you to the right page in the GCP console, and this link here takes you to the instructions on how to do it, which is just a page in the documentation. Okay, and so there were two parts to set up, both under credentials. So both setup parts were under APIs and services credentials. Okay, and the first part was to create this OAuth consent screen, and the second part was to create some credentials, some OAuth client ID credentials, using this template and filling it in with your own information. And then those go then into the deploy form. The resulting client ID and client secret from that setup go into the consent form, or sorry, the deploy form.
And those are important because what we're doing is we're setting up that identity-aware proxy, which means that no one can get into your cluster unless they're authenticated with your account. And your account is linked to that client ID and secret ID.
Yeah.
Because what it's doing is it's setting up a public IP. You're getting a URL out of it, so we don't want anyone randomly trying to access it.
Yeah. Right.
Okay, was everyone able to create a cluster? The deployment name, KubeCon, is what's listed in the Code Lab. Yes. Okay, if everyone's clusters are up, spinning, creating.
Like the same IP, probably.
He got off the Wi-Fi, did through Verizon or whatever, and got right on.
Yeah,
So.
I think it's like, it looks like it's, 90 clicks all in the same minute from the same IP. I think is probably what
Yeah, it's inbound. It's less than some IP, right?
There would be the same IP.
Thanks for helping troubleshoot, Pat.
Yeah. Yeah, that throttling is because we think is because you're all coming from the same IP effectively, as far as GK is concerned. But I think that those of you who are getting that throttling message, I think we'll sort of naturally space it out. You know, try again in half a minute or something like that.
And if you're stuck, if you're not able to create a cluster, just raise your hand.
Just wait.
Just try again.
Yeah, we think it's because we're all effectively coming from the same IP, so just wait. Yeah. Mhm. But that seems excessive because they probably want to do that for the whole.
How many people are still seeing the quota exceeded error?
Oh, only a few. That's promising.
It's running into like basically like an SSL SSL connection error when he tries to open Deployment Manager. I'm wondering if that's something I ask or should I ask?
Manager?
Is anyone else seeing an SSL connection error when you try to open the launcher page? Okay.
Okay, I think it's just that guy then.
Okay.
Yeah, all right.
Did you try adding the HTTPS manually
Yes,
using a different browser?
we did try that. Yeah, we tried that as well, Firefox. Adding it manually. Yeah.
So instead of HTTP, just adding the
yeah,
S.
we tried. I don't know. All right. I think it's probably something that's
Okay, I'd say let's move on and assume that.
Okay. We're going to go through a couple slides while you're waiting for your clusters to spin up. And if you're having trouble, just keep your hand raised.
Yeah, and if you're having throttling errors, just try again in half a minute or something like that, and hopefully it should sort itself out.
Okay. So if you're building a machine learning application, there are some really common challenges that you'll be facing. One of those is just the process of moving code from one physical environment to another. The code doesn't just, it's not just conceived in production, it comes from somewhere. It comes from a staging environment, a test environment, a dev environment. At some point, there was a human sitting in front of a laptop, pressing keys. And like our friend Klaus, the forklift driver, is aware, moving code from one physical environment to another can lead to death and destruction.
It looks like.
So what we need is something that gives us portability. We want to be able to forklift code from one place to another. And portability is what allows us to package all of our pieces together, not just our application, but everything that describes our infrastructure, to put it into one nice, neat little package and be able to move it together. Because there's a fundamental difference between running things on your laptop and running it in production or anywhere else in the cloud. Another big problem is complexity. We tend to have this sort of outsized view of the machine learning components within our application, but it doesn't necessarily reflect reality. We generally see something closer to this, where all of the supporting pieces, that everything surrounding that machine learning model, that's really the bulk of the system that we're building and what we need to support. Before we can even build models, we need to collect our data, ingest it, explore it, analyze it, validate it, transform it, and then we can split up into test and training clusters. And from there, we can turn it into a format that our models understand, that we can then use to build models. Once we've done that, we need to validate them, version them, audit them, and distribute them. If they're too big to fit on a single node, we want to be able to split them up across resources. And when we get new data, we want to update our models, make sure that we're training them continuously. Those models live somewhere. They live inside an application, which means a lot of business logic. That could be a giant tree in and of itself. There's infrastructure for serving that and for having a UI so that users can interact with it. And that application lives somewhere. It lives inside a platform. And all of the familiar tools like monitoring, logging, robust CI/CD processes, all of those are in addition to your machine learning models. So to handle that type of complexity, we need something that gives us composability, that allows us to create logical groups, modular components that we can then reuse. Another big problem is maintaining all of those pieces. But are we able to identify errors, to resolve them, to fix them, recover from them, and prevent them from happening again? If we do fix bugs, how quickly can we do that? And if we introduce new bugs, can we roll back to previous versions of our application? And we need something that's composable, that can automate many of those processes and shorten that development life cycle. And the last major challenge is capacity planning. When you have a machine learning application, you have pieces that have very different resource footprints. Training is very resource intensive. Memory and CPU, it hogs all of them. And even when you have established patterns, it can be difficult to use your resources efficiently, not to mention when you have spikes, like data fluctuations, when you get too much or too little, more than you're expecting, or if you just have a lot of users on your system and the load is high. We need something that gives us scalability, that's Kubernetes native, can leverage all of the scalability goodness that these thousands of contributors have added to the Kubernetes platform. And that allows us to provision our resources automatically. So let's check on our cluster. Does everyone have a GKE cluster up and running? So if you go into the Kubernetes tab, do you have a green circle with a checkbox?
This is what we want to see.
Who
Green
has
check
that?
mark.
Raise your
Who has a green check mark? All right. So, so you'll see in, well, I won't go back to the launcher page. The IAP setup is probably still happening, but there's some more cluster setup that we can do while that is taking place. And what we're going to do is we're going to set up a node pool, another node pool that contains a GPU-enabled node. And to do that, we're first going to, on the command line, so this is in the Cloud Shell. Oh, great. We're going to first run this command, which has the effect of setting kubectl, the command line utility that you're all probably familiar with. And by the way, kubectl is the correct pronunciation, in my opinion. We're going to set it to the credentials of the new cluster we created. So that assumes that you've set these environment variables properly previously. And if you haven't, you'll need to do that now. OK. And then, just to test it, we're going to run kubectl get nodes. Just see what we've got. All right, we've got 2 nodes running. So these are regular non-GPU enabled nodes in the Kubernetes cluster. What we're going to do next is we're going to add a GPU node pool with 1 node. And so this is how we're going to do it. So again, double check that all your environment variables are correct, including the zone. And we're going to tell it to use K80s, 4 of them, for this node. OK. So I'm cutting and pasting this command into the Cloud Shell to fire up my new node pool, which will be associated with the cluster that we just created. And this might take just a few minutes. All right. I think while we're waiting, we'll.
Okay, so we talked about a lot of the challenges, and this is what went into the creation of the Qflow platform. The main goal behind it is to make it easy for everyone to develop, deploy, and manage portable, scalable machine learning everywhere. So we care about, number one, portability. We want to be able to move our application from one physical environment to another, and not just the ML pieces, but the entire stack, everything that describes our infrastructure, all those supporting pieces. We also care about scalability. We want a Kubernetes native solution because this reduces the variability between our environments. This means that we can move it between on-prem and different cloud providers and Minikube. And it also means that we can leverage all of the magical networking goodness that Kubernetes provides, and services can just call each other by name instead of having to worry about port conflicts and where things are running physically. The third thing we care about, composability. We want that single unified tool for running processes that are very common in machine learning. We want to be able to wrap everything up into a nice, neat package and tie a bow around it. So we don't want to just support the application that's running in production. We want the whole life cycle from design and exploration all the way through test, staging, production environments. And then we also want to support changes to production, so going back and building new models and replacing old ones. And we want support for specialized hardware like the GPUs that you're instantiating right now, and TPUs. TPU stands for Tensor Processing Unit. It's like a GPU, but it's specific to running in Google data centers. It's also a hardware accelerator. Because if you know what you're doing, you can use those to reduce costs and improve your model performance. Qflow is entirely open source. It's for anyone who's involved in building a machine learning application. And we have a quarterly release cadence. We just released the 0.3.4 branch. That's what you're using today. You're using the latest and greatest. And it's Kubernetes native. That means it runs anywhere that Kubernetes runs. We're using GKE today because those are the resources that we have access to that we can share with you. But you could run this on any Kubernetes cluster. It uses vanilla open source Kubernetes APIs to manage machine learning tasks. And it does this by providing custom resource definitions to do things like distributing training. You'll see a lot of familiar Kubernetes patterns, like the use of loosely coupled microservices and managing your infrastructure declaratively. It uses an open source tool called KSonnet, which is essentially a templating language for Kubernetes. And this is part of how we're able to support the movement of an application between different environments. And we include support for multiple machine learning frameworks. TensorFlow and PyTorch are two of the most common ones that we see. You can use whatever you'd like. So let's check on our cluster. Once we have it up and running, we'll move.
Node pool is doing.
Yeah, from there we'll move to the Qflow pipelines dashboard once we have a full cluster.
All right. So hopefully you see, or will soon see, something that looks like this, which indicates successful spinning up of your new GPU node pool. So, and it can kind of take a few minutes, so give it a bit of time if it's not quite finished. The one additional thing we need to do to get our cluster properly configured is we need to run a daemon set, a Kubernetes daemon set that watches for GPU-enabled nodes, and anytime it sees one, it installs an NVIDIA driver on that node. And so because it's a daemon set, it works, if you were later to add new nodes, those would be detected and the drivers would be installed on them as well. Okay. So I've just installed this driver, so that means that or the daemon set, so that means that the GPU node that I just created is going to have those drivers installed. Okay. And so the last thing that we're waiting for is the completion of the IAP setup. And you may see this page redirect when it's done, but you can, which it'll hopefully do, but you can also just check that it's ready by following this link, a link that looks like this. So the first part of the link is your deployment name, which should be KubeCon. So this is the IAP endpoint that we've set up. KubeCon.endpoints, then your project name, then cloud.goog. All right. So, and again, try that. You need to, it's set up to be auth against your CodeLab account. So you'll want to do it in the same window as you're logged into the GCP console. All right, so let's see if we can get to. Oh, I think I just saw it redirect. Let me close this. Yeah. All right. So my the click to deploy page, when it finished, redirected to the Kubeflow dashboard. It's very exciting. So this is what this looks like. And I don't know if you can read my URL at the top of the browser, but it follows that structure that I just mentioned. First is the deployment name, kubecon.endpoints.projectid.cloud.goog. And that's in the CodeLab doc.
So at this point, we have a full cluster. Everything is installed on it by default. So this is your sort of baseline for from here on out, you can add your application on top of it. This is the latest and greatest Kubeflow installation. So if you are having trouble accessing your external URL, what you can do is port forward to the ambassador service. So do you know how to use port forwarding with kubectl? So it's a kubectl port-forward, svc/ambassador, and then you give it a port 8080:80. I wish we had a whiteboard. I was really hoping we'd have a whiteboard.
Unfortunately, I don't think we have this in the CodeLab doc, although the TAs can, the TAs can spell it out for you more carefully, yeah.
But essentially what you do from within the Cloud Shell, if you're familiar with port forwarding using kubectl, you port forward on 8080:80, so you're mapping port 80 inside your cluster to port 8080 locally. And then from the Cloud Shell, you can access port 8080. Do you want to show?
Yeah. So if you want to port forward, instead of using the IAP setup, then run the port forward command from the command line. Let me just see if it's in my history.
I mean, I could type it.
It's not there. Yeah. Do you want to just type it?
Yeah. So if you can't access your external URL, first of all, check your OAuth settings, because one of those strings that you had to paste in may not have caught before you created. But if you have no other option, because you won't be able to access JupyterHub if you do it this way.
Yeah, and unfortunately, this workshop, since it's relatively short, we probably don't have time to do it like a whole another redeploy. So if the IAP setup is not working, then port forwarding is the way to go. So do this from the Cloud Shell, and once you've done that,
Oh, we need the namespace.
oh yeah, we need the namespace. The service is running in the Kubeflow namespace in terms of the Kubernetes cluster. Yeah.
Okay, so if you port forward, that gives you access to that single entry point. This is a reverse proxy, which then fans out to all of the other components inside your cluster. And then you can access that local port 8080 by clicking this web preview button.
So once you've fired up the port forward command, the second piece of that is to go to this web preview button here, which looks to me like a little eye in a browser. Click on that, and then click preview on port 8080. I'm not going to click it myself, but that's what you do.
And that will land you at that same central dashboard.
That same Kubeflow dashboard.
The problem with accessing JupyterHub is that it has its own proxy inside, so it kind of messes up the port forwarding. I think there's some people in the community who are working on a replacement for that, but for now.
Yeah.
If you can access your external URL, that's what you want to do.
Okay. So now, either via the IAP endpoint or via port forwarding, we can get to our Kubeflow dashboard.
Oh, you might want to run that port forward command in a new tab, in a new Cloud Shell tab, just because then you'll
Yeah.
lose your environment variables.
Yeah.
Or run it in the background with an ampersand.
All right. So what we're going to focus on for the rest of this workshop is Kubeflow pipelines. So I'll talk a little bit about what the pipeline is doing, but because the training step of it actually takes a while. It's a big model we're training, and it's kind of slow to train. I'm going to walk through how to launch the pipeline, to run the pipeline, and then while it's running, we'll go look and see what it's actually doing and how it's put together. So click on Pipeline Dashboard from this dashboard, and I don't know if you can see my URL, but you can also get to it from your IAP endpoint /pipeline/. Don't forget that and /. So what you should see is something that looks like this. This is a bunch of sample pipelines. We're actually going to upload a new one. We're not going to use any of these, but later you can visit the Kubeflow documentation and explore some of these pipelines. Okay, so let's go back to our CodeLab doc and see how to upload and run a pipeline. So what this pipeline is going to do, just at a really high level, it has 3 steps. The first step, so the goal is to train a big neural net model, a TensorFlow model, to predict GitHub issue titles based on the GitHub issue body. And so many thanks to a colleague of ours from GitHub, Hamel Hussein, who built an original variant of this demo and also provided the data that we're using for it. So tensor to tensor model is, if you're interested, explore that link. It's really nicely packaged set of APIs for running different variants of essentially different kinds of sequence-to-sequence models, which are good for learning how to do summaries, how to do translations, building chatbots, things like that. So we're basically using this model for predicting, taking as input GitHub issue bodies, predicting the title. And unfortunately, it's very interesting. I recommend you look at that link more later. We don't have time to do it justice here. So for this pipeline, we're going to just train it a few steps. We're starting from, it's a TensorFlow model. We're starting from an existing checkpoint because it would take way too long to train the whole thing and to a state where it would do anything interesting. So we're going to train it just a few steps. That's step 1 of the pipeline. We're going to train it for a few training steps. That's step 1 of the pipeline. Step 2 of the pipeline is to take the resulting model and stand up a TensorFlow serving instance. So TensorFlow serving is part of what's bundled with Kubeflow, and this is a library that it's open sourced. It comes out of a Google project called TFX, which is building open source pieces of useful pieces for productionizing machine learning workflows. One such piece is TensorFlow serving, which lets you scalably serve your trained models. So that's step 2. Step 3 of the pipeline is to just launch a little web app, just nice UI to get predictions, GitHub summarization predictions. And just out of curiosity, who here would sort of label themselves a machine learning practitioner or data scientist? A few of you. Okay, good. Forgot to ask that earlier. I think probably you mostly would label yourselves Kubernetes experts probably rather than data scientists. All right. So the first thing we're going to do is we're going to download the pipeline, which is defined in a Python script, and compile it, and then upload it to the Pipelines UI. So download it to the Cloud Shell, like this. And the what you're going to do is you're just going to, so this is the thing I just downloaded. You're just going to run this script, and that compiles it. So I'm going to do Python 3. This requires Python 3. Like this. Okay. And you can see now we've generated this tar archive. That is the compiled pipeline. Under the hood, it's a bunch of kind of hairy-looking YAML. And that's the thing that we're going to upload to the Pipelines UI and run. So we'll get that going, and then we'll take a closer look at what the pipeline itself is actually doing. So to upload it, you'll since you're using the Cloud Shell, you have to do just one extra step. You're going to need to download that file to your local machine. This is like sort of the only point where you need to use your local machine. Download the file to your local machine so that you can upload it in the file picker in the web UI. So to do that, remind yourself of the directory that your account has. So mine's home devstar 801. Let me move this to the top here. Okay. Download the file. I'm going to do one more thing. You might also want to cut and paste the name of the tar file. So this is what you're going to download to your local machine, like this. Sorry. By going to this three-dot menu here, clicking Download File, typing in the fully qualified path, like this, and downloading it. And it just goes to whatever downloads folder your browser downloads normally go to. Okay, so now we can upload it to the Pipelines UI. All right. So we're going to click Upload Pipeline, upload a new pipeline. We're going to choose the file that we're going to upload. Okay. I'm actually in a different directory, so this is not my downloads directory, but I'm going to click on the equivalent here. Give your pipeline a name, whatever you like, and click Upload. Okay, so now you should see this new pipeline listed in the list of pipelines. If we click in on this, we can see a static analysis of what the pipeline does. So static meaning that we don't know. There's actually a runtime condition in this pipeline. We'll look at that in a second. So this is the static rendering of the pipeline before its runtime instantiation. All right. Next, we're going to start an experiment. So with Kubeflow pipelines, for any given pipeline, the pipeline runs are grouped, have a logical grouping in terms of experiments. So you set up an experiment, and then you do a bunch of runs under that experiment grouping. And these runs can be like on demand, or you can actually schedule them you can schedule a given run to repeat periodically. We're not going to do anything like that for this. We're just going to do a one-off run. So I'm going to start an experiment, and the name can be anything. Okay, I'm going to click Next. Now I'm going to start a new run. Let me make this just a little bit bigger. Okay. So the run name can be anything. We're running it under the umbrella of the following experiment that we just created. Okay. And now you're going to need to set 3 input parameters to this pipeline before we can run it. So the first is your project name. And so that, going back to the home page here, that is your project ID. Okay. I'm actually not going to share my own GitHub token on the video, but here's where you type in your GitHub token. And here is where you put in your GCS bucket that you created earlier in the workshop. And this needs to have prepended this GS / construction. You can see it just below, in the field just below as well. Okay, so whatever you named your bucket, put that bucket name in, and you can also, like, if you want to put the results of this run into a subdirectory, you can do that. So I did /kc for KubeCon. All right, and you can leave all the other parameters the way they are. Okay, so these 3 were the ones you needed to pay attention to. All right. Now we'll click Create. And I should probably add the qualifier that this UI is currently a little bit alpha, and it doesn't do auto refreshes maybe how you would expect it to. So you're gonna need to pay attention to the refresh button and periodically refresh to see what's going on. So I'm gonna click into the run, and the first step of the run has begun. Right now it's creating the container. If we want to, we can go under the GKE, Kubernetes Engine, workload panel in the Cloud Console, and we can look at the pods and we can kind of see what's going on here. So you can see my container creating. Once it finishes spinning up the pod and actually running, we'll be able to see something a little more interesting here in this dashboard. And we'll come back to that because even though we're targeting this training step to run on a GPU node, I'll show you how we did that in a second, it still takes a while. It's just a big model, and there's a lot of data. So let's, while we're waiting for that to do something more interesting, let's go back to talking a little more detail about what pipelines actually are.
Okay, sorry. Oh. All right. So let's take a look at what's inside the version that we're looking at. So everything in blue was created since v0.2. So we have this IAP. I know some people are still waiting for that to provision for you to get your external URL, but that gives us a single entry point into our cluster that's authenticated. And from there, it goes into several different ingress components. I've just sort of lumped them together. There's quite a few there. I've lumped them together and just called them ingress. One of those is Ambassador. That's that reverse proxy that you may have port forwarded to while you were waiting for your URL to provision. And that gives us access to all of the other components within our cluster. So we start from our central dashboard. This is our single pane of glass. This is access to all of our other dashboards. We have Jupyter Hub, which we'll see a bit later. We have a TensorFlow job dashboard where we can see details of the TensorFlow jobs that we've run using our TF job operator. And then we have these 3 new components. We have an Argo dashboard. Argo is a workflow engine. It's what powers the pipelines. That's what's inside that tar file. When we compiled it into Argo YAML. We have a hyperparameter tuning tool called Katib. This is new. This is an implementation of the Vizier paper, if anyone read that a few years ago. It's a way of performing hyperparameter tuning automatically by just calling a CRD. And then we have our pipelines dashboard, which is where we just were. This is where we've used our Python SDK, and we've generated something and run it from that UI. Each of those components has a corresponding controller, one for Argo, one for pipelines, one for Katib. And then we have our job operators. There's one for TensorFlow and one for PyTorch. And what's important to note is that this is by no means all of the components that exist in Kubeflow. There are a lot more you can mix and match. This is just what you get with a default install. So what's new since 0.2? We saw our click-to-deploy tool, but for deploying clusters, that will give you a GKE cluster and all of the corresponding software to go along with it. But you could also use the command line version of that. That's called KFCTL, and that separates out the creation of the cluster from the installation of Kubeflow. So you can script that out and customize it to whatever you need, run it on any platform. It's not, click to deploy right now is GCP only, but KFCTL is where you would install it on another Kubernetes cluster. We also have different tools. Argo, we talked a little bit about that one. What's cool about this is that it's not just a workflow engine, but there's a really neat continuous delivery tool. So they have something called Argo CD. There's a talk later today by two of our colleagues, David Aronczyk, one of the project founders, and Jay Smith, another Google engineer. And they talk about running CI/CD on Kubeflow, and I believe they'll show using Argo CD. The PyTorch operator, it gained parity with the TensorFlow operator so that those APIs look very similar. So depending on which one you're using, you don't have to do a lot of context switching. Katib, this study job CRD, this is what allows us to run hyperparameter tuning more easily instead of having to keep track of it. Instead of having to run it manually and keep track of it, that interface will help us determine the best parameters for running our models. And then pipelines, which was one of the biggest components that was part of this release. This is what we just instantiated. This is what we're waiting to run, and it's a way to run your ML workflows from end to end, data processing, training, serving, and then instantiating your UI. So we'll see that in action as soon as our training finishes. So it's for orchestration, setting up dependencies. You can set up scheduled pipeline runs so that you don't have to deploy it manually. It integrates with different services, both within Kubeflow and outside on the platform. So if you want to call ML Engine, if one of your steps, instead of training in cluster, you want to use ML Engine to do that, you can do that. Or if you want to call a storage layer externally, you can access all of that from within pipelines. The Python SDK means that it's easy to create libraries and share components. So we can have sub-pipelines that we then pull into other ones, reusable components, and track the progress of our pipelines over time. So for every run, we can see the results of that run, and we can access the logs and see everything that was associated with that. It has good notebook integration. That's sort of the last step of this code lab. We'll look at how you can interact with pipelines from a notebook. All right, do you want to check on it and see? Yeah, so we might not have time to get to that, but it is described in the code lab.
Yeah, we don't have time. You can do that on your own later.
Yeah, so let's check to see if that.
All right, yeah, let's see how our pipeline's going. So remember I said the refresh button is your friend? All right. So now the train step is running. It hasn't finished.
Is your mic on? Can everyone hear her?
Yeah. Okay.
Thanks.
Is it on? Yeah, all right. All right. So we can take, now that it's properly running, the container creation is finished, we can take a look at the logs. So this is a cool feature. This is actually the pod logs, the Kubernetes pod logs, and we can see how the training's going. It's, remember I told you that this is a big TensorFlow model, and it's training on a lot of data. So really, if we really would set this up with more high-powered GPUs if we were doing this for real. We're just training it with a few steps. So it's nearly done. We'll come back to this in a second. And while we're waiting, let's take a look at what the pipeline actually is. What's that Python script look like? Okay. So there's a link to this file in the code lab. Right here. Well, the underlined closer look in step 4. That takes you to this file. So this is a Python script. Let me make this just a little bit bigger. And it is this Python script that we compiled to define the pipeline that we're running. So it has, the pipeline has 3 steps. This first bit up here, we're defining the pipeline parameters, the values that we pass in when we do a pipeline run. And you can see how we define some defaults here. And here's where we define our pipeline steps. So each, under the hood, these steps are using Docker containers. And so each step definition includes the link to the Docker image that it's going to pull down and use when it runs. If you're not familiar with GCR, this is Google Container Registry. So this is the Docker image that we're using for this step. And these are the parameters to pass, basically to the Docker containers endpoint. And these are, if this isn't optional, these are any outputs that the step has. And other steps in the pipeline can access as outputs. So training step, here's the serving step where we spin up the TF serving instance to serve our train model. And we've got a few directives here. We say that the serving step goes after the train step. So we're defining an ordering dependency. And then this is something that will be of interest to the machine learning practitioners. Here we're saying the training op, we want to run it on a Kubernetes node that has GPUs. So in fact, if we hadn't to set up that node pool, then the pipeline wouldn't have known where to place that node as defined. It's looking for a GPU-enabled node for doing its training. And then finally, here's the last step. This is the spinning up the web app. And just to show the use of a pipeline conditional, we're making the decision of whether or not to spin up that web app, whether or not to do that last step in the pipeline, based on some output from the training step. So we're checking the training output, and we're using that to make a decision of whether or not to spin up the web app. In the pipeline you're running, you're spinning up the web app. And again, we indicate that this last step goes after the serving step. Okay. So so that's the pipeline definition that we compiled. And this repo, actually, if you want to poke around in it more later, you can see the actual container image definitions, the Docker files, et cetera, that we're using for these steps. But let's go back and see how we're doing with the training step right now. See if it's finished. Okay, yes. Training is finished, so that means the pipeline itself should finish soon. And something interesting that we can do is go to artifacts. So I clicked on train, and then I clicked on artifacts. And so this is part of the step definition, part of how the training step is defined. We told it, look to these files for supporting TensorBoard. And this is part of the Kubeflow install as well. So we're just going to click on Start TensorBoard, and it's going to, for those who aren't familiar, since I think not many of you are TensorFlow users, you'll see what that is in a second. It's like a monitoring and metrics dashboard. And it shows you the progress of your training runs and lets you compare across runs. first time you start it up, it takes just a few minutes. And I think that the UI currently has a little bit of a glitch where it doesn't indicate correctly when it's actually started up. So I'm going to click on this and see how it's doing. Yeah, all right. If it just spins, click on the, once you've clicked on Start TensorBoard, give it a few seconds, click on this pop-out, and then click Open TensorBoard. Okay. So we don't have time to go into detail on what's going on with TensorBoard, but if you're training TensorFlow models, this is kind of where you live. It shows you all sorts of metrics. It can show you histograms. It can let you browse your model graph, the neural net model that you're using, all sorts of stuff. So when you're using Kubeflow pipelines to do TensorFlow training, this is a super useful feature. All right. And unfortunately, we don't have more time, but the integration is really nice. All right, let's refresh again. Okay, so we finished the entire pipeline. We've trained the model, cheating a little by starting from a checkpoint. We've served it to TensorFlow serving, and we've stood up this web app that is going to let us make predictions. So let's go to that app. And I'm actually going to go to a different installation for this, just because I kind of cheated earlier and didn't give my GitHub token appropriately. So now I'm going to go to a different cluster that actually does have the GitHub token set correctly. All right. So you should see something like this when you go to the web app. And the URL is in the code lab, and you need to make sure that you include that trailing slash. So here's the, if you're connecting through IAP, the endpoint construction looks like this. With the, don't forget the trailing slash. And if you're port forwarding, just add slash web app slash to the end of the Kubeflow hub URL. All right. So, oops. So you should get something like this. Behind the scenes, this is talking to the trained TensorFlow model that we're serving with TensorFlow serving on this Kubernetes cluster using Kubeflow. So I'm just going to click populate random issue. So you can click this multiple times and wait till you get something that looks kind of interesting. I'm not sure if this qualifies for that. And then click Generate Title. And in just a few moments, just right below that button, you should get what the machine learning model thinks is the right issue title for this issue body. So let's see, how did it do? It actually didn't do that badly. That's a pretty good title.
Yeah, and this is to kind of correct the very common issue like broken or just like doesn't work for me. This is a way to give you more informative titles so that you can actually triage issues instead of trying to dig through all the text.
Yeah. So this is kind of an understated UI. I feel like this should be blinking or something. But this is the machine learning generated title. And if you want to, you can use the this field and enter a GitHub issue URL instead, and that's where the use of the API token comes in, and generate a title for that instead. Okay, so this was this is a Kubeflow issue, and it does pretty well in this. Choose services were incorrectly using the same name, and the predicted title by the neural net model is incorrect service name. So, that seems okay. so there's a lot of heavy lifting and sophisticated machine learning going on behind this web app.
Okay,
All
I
right.
think we're running low on time.
Yeah, so we will skip the notebook part. Yeah.
Yeah, do you want to just open up Jupyter Hub and just show? So
Yeah.
you can follow the code lab on your own separately. So instead of running it from the notebook, there's some
Yeah.
really cool stuff there that interacts with pipelines using the Python SDK.
Yeah. It's, you mean like what?
Like, what's the training behind? Why did you create something that can generate this kind of really accurate?
In terms of the neural net architecture, it's it's kind of it's part of the family of sequence to sequence models, and so it essentially expects sequences as input and can generate sequences as output, and there's all sorts of variants on that, and so one of them is how we're using it. Another variant is like translation, say from English to German or whatever. So, and the tensor to tensor package makes it very easy to pick the variant you want and to do the different phases of things that you need to do to train such a model. And unfortunately, we don't have time to go into details, but follow the link to tensor because they make it really easy and nice to use. You sort of don't have to understand much about the guts of the model at all to use it. It's very nice, very nicely packaged.
And all of the code that we're using in this code lab is on GitHub. You'll be able to view it yourself, so you can look at it in more detail.
Okay, so let me just show you oh yeah. Yes.
Nice. The comment was that the machine-generated title was able to understand Portuguese.
Oh, yeah, I'm sorry, I misunderstood that. Yeah, the training corpus had a bunch of different languages, and it actually, I used Google Translate to like test a few of them. It actually did pretty well. Yeah, which sort of goes back to its how one of its variants can do translation. It's much the same what we're doing. Okay, so let me just, we're not going to go through this, but let me just quickly show you something we don't have time. It's in the code lab. Pipelines itself and its SDK, you can build and run pipelines from a notebook. And there's a notebook, a Jupyter notebook. There's a notebook that's part of this code lab, the sort of the last step that we're not going to get to, that shows you how to do that, shows you how to construct your pipelines, compile them, and run them just all from a Jupyter notebook so that you don't even have to go into the command line at all. It's pretty cool. And Kubeflow includes a Jupyter Hub installation, and so this is what it is. This is my working area, and you can see I've done a little bit of stuff already. And if I actually let me go to the fresh code lab account here and show you how to spawn up one of these Jupyter Hub installations. The first time you visit this link, you're going to get something that looks like this, and you need to pick a notebook image that you're going to use. In the code lab, we suggest that you use the CPU TensorFlow 110 image, and then click Spawn. And it'll take a few minutes. We won't let it finish, but once that comes up, you'll have your own notebook, Jupyter Notebook, Jupyter Hub installation, your own notebook workspace, and you can do whatever you want in. There's all sorts of commonly useful libraries installed. You can install other stuff, and one thing you can do is you can build and run pipelines.
And
All
that's
right.
running within the cluster. It's
Yeah,
not running
so
locally.
this is running within the cluster. This is part of the Kubeflow cluster installation.
Okay.
Okay.
So we only have a couple of minutes left. We'll just switch to looking at the roadmap. So what's coming next for the project? What's part of the O.4 release? So I think we're going to be rolling an O.4 release candidate on December 17th. We'll let that bake for a few weeks and then finalize that in early January. And what you can expect to see in there is some better Jupyter Notebook integration. So in those spawner options, you saw some advanced details. You can request GPUs. We'll be adding support for persistent volumes. And fairing, which is part of the code lab, is where you're interacting with pipelines from the notebook. There's a lot more to do with that. That's coming. TFJob and PyTorch operators will be in beta. Katip is adding support for TF Job. Richard just told me he merged that just a few days ago. Thank you, Richard. That's really exciting. A few pipeline features, and all of this getting ready for the 1.0 release, adding some of the more important enterprise features. And then if there's anything missing from this list, please let us know. You know, here are all the links where you, if you want to get involved in the project, you're more than welcome to. Very nice community. There's a few contributors in here, very nice people. But thank you very much for attending.
We need to have them clean up. Yeah, I'm sorry to rudely interrupt Michelle. I forgot a step. Before you leave, before you shut your laptop and leave, please do one thing, which is go to your Cloud Console tab, click on this left-hand menu, and look for something way down here at the bottom called Deployment Manager. It's under Tools. And before you go, please click on your Kubeflow deployment and click Delete. Thank you for that. so please delete the whole deployment. This cleans up not only the cluster, but other stuff that it has installed to support the cluster. So under the Deployment Manager menu, click on your deployment name, and then click Delete.
And you can reproduce all of these steps with your own account. There was nothing special about the accounts that we gave you. We do have some credits. If you would like some credits to run this on your own, we have some vouchers. Just come see us afterwards.
Yeah, come up to us after if you want to try this in your own GCP account.
But thank you, and we'll be around if you have questions. I think we need to vacate the room, but really appreciate you being here. I hope this was useful. Thank you very much.
Yeah.